the Regolith mining competition. NASA's fourth annual event challenging college students from around the world to design and build a robot, then navigate their way to success. This contest may require a little more than just the force to become victorious. Which teams have the right stuff? Find out next on NASA Edge.
This year's Regolith mining competition was awesome.
Yeah, we had 50 teams, 32 U.S., 18 international.
The international teams that came to the competition overcame quite a few obstacles getting here to Florida, but they got into the competition and we saw some pretty good runs.
And we're not going to cover all 50 teams, but we are going to take a look at a few NASA Edge highlights from this year's competition.
And one of the teams that I thought was going to do pretty good was North Dakota.
Yeah, they went from that scooper to the drum design this year, and they looked pretty tough.
Yeah, they were my pick to win this year.
We were very intrigued by you coming back with a drum design this year as opposed to the scooper that you've had in the past. Tell us why you decided to go with the drum.
We know previous years have had a little bit of a struggle getting into this material, and you have to have the bucket at a certain angle. With this drum design, as the bucket comes around, the scoops go sweep through that maximum angle,
right,
and really helps us scoop up as much as we can. We spent quite a bit of time last week actually testing. So we got into about 30 seconds of digging was about our maximum weight.
And you don't have sensors to tell you that, so you literally have to do that by experience and test.
Yeah,
wow.
If we get too heavy, the robot tips forward and we got to dump some back out.
I asked him, how much time did you all spend on your robot after your first run? And he said that we spent probably about 20 minutes from their first run to the day on their robot, because it wasn't broke. They weren't really trying to fix it. They were just trying to gain little points where they could, and that shows that they came here ready to play.
And they have a solid design.
It's rock solid.
Now, there was one point where you had a rock and it looked like you were tipping over a little bit, but with just the robustness and the sheer power and weight of your vehicle, you just overcame that obstacle no problem.
That's one of our best attributes, is our robustness. I don't think it's going to break with anything in that pit. We were just about over it. I told him to back up, so he did, but I don't think we had to.
You set the tone, okay? So now that you set the bar, you're going to be in first place. Now you have to wait for 2 days. What's the stress level going to be like?
It's already high, so I don't know. We're just going to try and enjoy Florida.
Franklin, you were on pins and needles that last day because we were wondering if North Dakota was going to be able to pull it off.
Yes, you're absolutely right. They were my number one pick, and they did pretty good for the competition.
And I really respect them for their transition from the scoop to the drum, because design changes, that's a big deal.
And speaking of design, the Florida Institute of Technology changed their design from last year, and even the materials they used to create their robot.
Now, tell us a little bit about this unique design. This is the first time I'd seen it, where you actually have a ballast. Explain how this operates.
When we first designed our robot, we designed it with the backhoe design, but we sized the bucket larger than what the chassis was able to actually excavate without having stability issues tipping forward. So I proposed a mass balance mechanism solely to add mass to the rear side of the chassis to balance out the scoop because of how large we designed it.
Now, I understand a lot of it was carbon fiber, so how did you arrive at that decision to do that?
The entire robot is made out of carbon fiber,
wow,
aside from the fasteners and the electromechanicals. When I first came to Florida Tech and proposed the idea for the robot to Dr. Reichert, he was like, that's a good idea, but you guys are going to need to go with carbon fiber. And I was really skeptical at first.
Right.
I didn't really understand the properties and characteristics of carbon fiber.
Right.
And then he made the first piece of the robot, put it in a 3-point bending test, and showed me that it wouldn't bend until we actually hit like 1,700 pounds. So I was
wow,
like, okay, I'm a converted person. I believe in this now.
Of course, a common problem for a lot of teams during the competition was communications, or comm issues. Describe for us what a comm issue is like in the midst of a run that clearly you were able to keep going.
So for some reason we kept getting disconnected. You're communicating with the robot from your laptop. So what happens is when you get disconnected in the middle of sending a command, that command sticks. So if you're going forward and you lose your connection, it's going to keep going forward. And that's pretty much what happened to us 3 times. So.
You know, when that happens, do you get a lot of frustration in there, or is it a pretty calm environment?
The first time, it was like, what's going on? What's going on? Then after that, I'm like, all right, calm issue. And then once we got control back, we were right back on it. So we stayed pretty calm.
How quick is the reset after you have a comm issue?
It was taking about 10 seconds to get connected back, roughly.
10 seconds is a premium in the arena, but we've seen some teams that never recover.
Right, that's exactly the first time it happened. We didn't know that we were going to get the controls back until we just waited, and then it stopped spinning, and then if you notice, we did a donut like in the first few minutes, and then it just stopped, and we were like, okay, we're good to go again.
I was really encouraged to see that teams could overcome these comm issues even mid-run during the competition.
Or even more complex issues is the fact that the international teams had to travel thousands of miles to Florida and reassemble their robots in the pits.
And one of the teams that made that trip was the Military Institute of Science and Technology. We were joined by our good friend Andres to watch their runs.
I'm really excited to see this because we love to see our international teams do well, primarily because they have just some really added obstacles in traveling so far. Now, I know some schools, even domestic schools, drive a long way, but there's nothing quite like a 24-hour plane ride to take it out of you.
Looks like the Military Institute is getting ready to dump what they've got to the point, and we'll see if they can line it up, make sure they get every last drop in there.
There we go.
Yeah. It's always interesting to see the techniques. Some of them just slowly get up to the hoppers. Others try to run over the hopper. Others just bang into it. Oh, that's
Wow,
comparable,
that
though.
is impressive.
That is pretty impressive, though, I have to say. That is looking, wow.
Wow.
I wonder if
Where's
they had
it coming
any.
from?
Yeah, I know. Did they have some stash somewhere?
22 kilograms.
kilograms.
They qualified. Qualifying run. Great job, Military Institute of Science and Technology.
That's awesome.
Dan Moy, you had a qualifying, great second run of the week.
Right, sir.
Tell us a little bit about it.
First of all, we tried. It got stuck. We changed our way. We keep it simple, and finally it worked. They're shouting behind.
What was your plan when you started off? Was it to go and get the most and qualify? Because I saw that you all mined in several different places the first time around when you came up with that large number of regolith.
What our team leader said that if you can collect anything in the first round, in the second round, whatever you can do, you just collect. Whatever you do, you just collect. He said, take all the risks because you have nothing to lose at second round. You just collect and just deposit. Whatever you can collect, just deposit. Because at the first round, what happened, we collected a lot, but we couldn't deposit.
Hey.
That's very shame.
Anybody want to say hello to back home?
Johnny bhai, Rejon bhai, আপনারা দেখতেছেন না জানি না, everyone, sir, we are happy like hell. Thanks to all Bangladeshi. Thanks all.
Excellent qualifying run by the Military Institute of Science and Technology, and what I really loved about it was seeing the regolith deliver, but out of that scoop, more and more just kept pouring out. Good job to those guys.
I tell you what, there were a lot of different designs during the competition, and a lot of teams employed different strategies. And we had a chance to talk to head judge Rob Mueller about those different strategies. So tell us sort of the scoring breakdown. How does that work? What's being scored?
The way the points are structured is that you can win with several different strategies. In the beginning years of the competition, it was heavily biased towards how much regolith can you dig. But there's more to it than that. First of all, you have to deliver your Lunabot to the moon. So if it's big, bulky, and heavy, it's going to be more expensive and harder to deliver to the moon, so we wanted to give the teams credit if they had a lightweight, compact machine. So we balanced it more. So if you have a very light machine that doesn't dig as much, you can still beat a machine that digs a tremendous amount of regolith but is heavier.
Right.
And the point system is fine-tuned so that you can employ several different strategies. And I think it's been successful because we've seen a variety of robots show up.
I think we've been seeing 4 primary designs. We've seen the scooper, the auger, the conveyor system, and then a drum.
Yeah, and then a few exotics.
Yeah.
Even though you might have the best design, you still might not win because something went wrong along the way. So you can have a very good design that's poorly built, or you can have a very good design that's very well built but poorly operated. Or you can have a very well operated design that breaks. So every team needs to strike a balance between operations, between design, between manufacturing, and then of course there's the big one, which is the autonomy, and nobody's managed to do autonomy yet in the history of the competition. Caterpillar has offered a special autonomy prize and said our corporate goals are to have autonomous machines working in mines. And so we would like to encourage the competitors to pursue autonomy. And so they decided to push on that angle so that they can meet their corporate goals by having more people interested in that. So independent of every other prize, there's a special autonomy prize.
Is it called a job?
Over the years, we've been talking about how this is important for Caterpillar because you're looking at the future generation of engineers here, right here at this competition, and you actually are hiring some of these students that enter these competitions.
Yes, we do. So, in fact, we have 5 now that are Lunobotics alumni at Caterpillar, and one of them is actually here at the event, here at the CAT exhibit.
Oh, that's great.
2012, so last year alumni of the event.
Wait a minute. So a new hire gets the joy of coming down to Florida
he's right back
to the competition?
Right back from where he was last year.
Oh, man. That's...
Hey, I mean, what better way to come back and give back to the
back to the whole
students.
event and the
that's
community.
A good point.
And it is kind of, it's becoming a true, I think, community. All of them are working on technology that we at Caterpillar are looking at and needing for the future and to provide value to our customers. And so we are looking at technologies all the way from things that help support manned operation and improve and support that operator, all the way through remote control, like many of the teams are doing now, to full autonomy. Right. And so we're seeing that, and these teams are getting real firsthand experience, real world problems, the same kind of problems that we deal with in day-to-day in the real world in that area. They're getting that experience here.
It was great talking to Eric from Caterpillar because throughout the whole week, the company showed a lot of outreach and support for the kids.
You know, it's interesting because outreach is actually a component of the competition. Each team has to come up with an outreach plan on how to tell people in the community about what they're doing.
And Blair, one of your favorite teams, showed up with their own special kind of outreach, Team Robocall, that actually enhanced our broadcast.
Yes, we're back and enjoying the benefits from Team Robocall that must have just won a coffee bean mining competition because they have delivered nice little cups of rich Colombian coffee. It's actually something very common here. Part of this competition, teams do engage in outreach activities, and one of the things that Team Robocall does is provide coffee, and that's part of their way of engaging the public. And let me tell you, I'm fully engaged. I'm fully engaged with Team Robocall.
They're influencing the scores from the NASA Edge.
I've already scored them 100.
Yeah. Oh, here goes Team Robocall going for.
Yeah. All right.
You're going to hear a big cry from the crowd.
That's a lot of Regolith they're dumping.
Yeah, it looks like, wow. There we go.
9.4 kilograms.
Yeah.
They got qualifying run.
We were just chatting, how long it's taken them to get here the last 3 years. It's been an awesome, experience for them, and to be able to accomplish the 16 kilograms they had today was huge. As you can see, they're all excited. I almost feel like I'm at a soccer game in Colombia.
I have to admit, I love the coffee that Team Robocall provided, but what was more impressive and certainly more important was not only did they deliver Regolith to the hopper, but they actually delivered a qualifying run for the competition.
Another good school, the University of New Hampshire, a veteran team to the competition, had 2 solid qualifying runs. How did things go from your perspective?
Very well. We got a little more than expected. We already have more than we did last year. And we even found out that we can fall in the crater and nothing happens.
I saw that when you guys were backing up. It looked like a big crater. And you guys went in and out of it with no problem.
No, we went in the crater at least 3 times, and we even pushed one of the rocks away. So.
Nice.
In fact, I saw there was one where you went to the hopper and he came back. You kind of elevated your front wheels, and was that by design or is that?
No, that was not by design.
Okay.
Were you driving?
No, I was not driving.
Okay, all right.
But were you nervous when you saw that?
Oh, I'm always nervous being in the control room.
So tell us about your design of your robot.
Pretty much, we made it as simple as possible. We're a third-year team, so we know that some of the complicated ones, there's so many things that can break. So we had a great physical design last year, so we used that again, and then we completely did an electronic overhaul, and that has apparently worked out very well.
As you approach this round from a strategy standpoint, were you just deciding to go all out and just,
go big or go home? We knew we wanted at least 5 scoops, and we made sure that most of our scoops had at least 10 kilograms in it.
Well, now how do you determine that? Do you have sensors? Is that by feel?
We don't, just by looking.
Yeah, okay.
We know that if, dust starts coming out of the bucket, it's a big one.
It was interesting. This is a robotics competition, and I was actually quite surprised that the University of New Hampshire mentioned that they used almost a spidey sense to determine whether they had enough regolith in the hopper. I thought that would have all been governed by sensors.
Well, speaking of sensors, the University of Alaska Fairbanks could have used some sensors to find their way to the bin. The University of Alaska Fairbanks, their excavator is pretty unique, but I don't believe they're going to get any points for not kicking up dust.
Well, I'm very interested to see this because...
It seemed like you collected a lot of regolith, and all of a sudden, splash.
We did, yes. Unfortunately, we didn't get any practice time on Monday due to the immense amount of teams lining up for that.
Right.
But we have been testing our robot in the sand pit. We can mine an impressive amount and collect an impressive amount, but we did not have practice, so we didn't know exactly how well the Lunabot would behave when approaching the Luna bin. We approached the Luna bin perfectly, started raising our dumps. The pilot could not quite see how close to the wall we were.
Okay.
Started to back up a little bit more, and the Lunabot just crawled right up the wall because of our tractions. Our mining conveyor, actually, we've measured it before. It mines an impressive 1 kilogram per second of material. The main problem we have right now is transferring that material into our side bins, and the method we're using right now is dirt flingers. It's not completely efficient, and that we lose a lot by overspill and that sort of thing because it can't quite move as much as the mining conveyor can handle.
Right.
But if we improve that a little bit, we can mine 1 kilogram a second in good conditions.
Wow.
Now, you say you want to put a webcam on there. Is that something you've brought with you already, or do you have to go back?
We actually already have one webcam mounted on it. We mounted it on the side, pointing towards the inside of the robot so we can see the inner workings of the robot while we're driving.
Okay.
We've programmed it to be really efficient in the frame rate, so it'll actually be a stationary frame until we hit the spacebar. It'll grab 1 frame every time we hit the spacebar, so
Right.
we can see exactly what's happening.
Nice.
1 frame at a second to conserve bandwidth.
And just for our audience, you do that because you are judged on the amount of bandwidth you use.
Exactly.
And so that's actually strategic because you want to be able to keep that communication bandwidth low.
As low as possible, and we are actually really good on that.
No, when you were making that second attempt, I was saying, you know what, they're headed toward the hopper. I was like, why don't they just lift their buckets up while they're moving and just go into the wall and dump at the same time? You actually started lifting your buckets up at the end, but your time ran out.
Yeah.
What was the thought process down that home stretch?
Well, actually, my coach just shouted, "Just dump them here."
One of the really important parts of the competition is that second run, and you saw that with University of Alaska after their first run, being able to go back and actually make adjustments for that second run.
Yeah, it's kind of like a stock car race. When they pull into the pits, they make mid-race adjustments to come out and hit the rest of the track, and that's one of the things that the University of Sydney did to make adjustments for their second run.
What happened? You guys basically broke the speed limit in the arena and got 82 kilograms of regolith. Good job.
Thank you.
Tell us about the run.
Well, that was pretty close to our practice run because we built our own pit in Sydney, pretty much the same size, but we haven't actually ran here on this pit with these sort of setups, so it's a bit different. And during our first run, we had serious latency problems, so it's a bit hard to control something at high speed. When you move it, wait half a second, and you're like, oh, I'm about to run into a wall, pull back, and there's all this oversteering. So it was just a matter of fixing that. This time we're lucky and didn't get latency. We took it out to the sandpits, made a few small changes, some code tweaks to make it faster, and just hammered the run this time.
Excuse me, but when you say code changes, is that literally some of your team members around computers writing programs?
Yes.
Wow.
So actually, after the last run, we remapped all the controls to make it faster.
The moves that you made with your robot were so quick, it almost looked like a remote-controlled toy car because you were moving and backing up. It looked like a DMV test. I don't know if they have a DMV in
It's called the RTA in Australia.
Yeah, you were really moving. Who was driving?
Me.
Let me ask you a question. Do you play video games?
A lot.
Good deal.
And I knew you were looking at the time to make sure you could get another run in, but you came pretty hard up to the bend. I mean, you actually, bumped into it a little bit. You were just being aggressive because you guys wanted to deliver.
Yes. Unfortunately, there's not enough time in the arena to actually slow down and take it nicely sometimes.
University of Sydney had a great driver, but I tell you, the next school that we're going to talk about really took that to another level. They're letting their robot do the driving with that elusive autonomous run. If I understand correctly, your team is going to attempt an autonomous run today.
Yeah, that's the goal. We were up till 5 this morning, worked through the night, getting everything squared away, running tests in the parking lot, even did some testing on the beach earlier in the week, and we've got all worked out. Okay. So we're going to give it a roll.
How many returning members do you have from last year's team?
We have 10 returning members from last year's team.
So what a great combination of having experienced members and the new members coming on.
Yeah, in fact, a fair number of members on our team this year are freshmen.
Oh, wow.
And some sophomores, and then we have a good mixture of juniors and seniors, and some super seniors. And
super seniors?
Yeah, the fifth-year students.
I was like,
see, we have a lot of
superheroes at that school? That doesn't seem fair.
Well, it's a little-known secret in Iowa State.
I'm joined here by Aaron, Nathan, and the entire engineering team from Iowa State who had a successful second-round run here in the arena. Aaron and Nathan, tell us about your second run.
We managed to avoid many of the issues we had for the first run in regards to communications, mainly by ignoring the problem entirely of making it work around regardless of communication issues. So that worked out. We took the initial approach of full autonomy. We went out there, mined material, and then started hunting for home, and ended up missing the target by probably about this much, so a quantifiable distance, and then let it spin around a few times trying to find it, and then eventually took over control and started digging ourselves.
Your faculty advisor, Jim, was sitting here on the set, and he was nervous. He didn't really let it show.
Why does he stay so calm and focused during the whole autonomy bit? He's just sitting there just calm.
I'm hanging on to this mic for dear life.
What was the thought inside the comm trailer when you knew that you were going to have to break away from autonomy?
Well, it wasn't too hard of a decision. We knew we had a fair amount of material in the hopper, and it's not too hard to get back to the bin, so it was more of a, shucks, 500 points. Okay, come back and dump.
So you knew going into this, based on the way that this is scored, that you really didn't need that much Regolith to take over first place. So why did you go for so much Regolith?
Because we put the work into it. I'll see how much we can make it do. So.
And well, you all are engineers. What do engineers do when they rejoice? Come on. Well, you know what? Jim was actually a little bit more enthusiastic than that.
Oh my goodness.
Oh my goodness.
15.3 kilograms.
Wow.
That is a record for us.
Wow.
Woo! Way to go, guys. Sorry.
All right.
I got a little carried away.
Jim's about to be ejected from the set.
Do you all have an Iowa State cheer?
Want to go for it?
Yeah.
Who are we?
ISU.
What do we do?
Science.
Yay. Hats off to Iowa State University for winning their second Regolith mining competition.
And congratulations to the 49 other schools who participated this year.
It's a great event. We really enjoy covering it. We look forward to coming back next year and seeing if Iowa State can possibly three-peat.
Yeah, we'll see.
You're watching NASA Edge.
An inside and outside look
at all things NASA.